All right, today we're jumping into a really incredible scientific story. It's got everything: a devastating disease, a hero that's literally the size of your fingertip, and a discovery that could change, well, everything. So let's get right into it.
Just try to imagine this for a second. A disease that steals your strength, muscle by muscle. A condition that slowly takes away your ability to walk, to even breathe easily, and ultimately, your time. For thousands of people, this isn't imagination. It's the reality of Duchenne muscular dystrophy.
Okay, so to really get why this breakthrough is such a big deal, we have to first understand the opponent. And it's a tough one, a genetic disorder known as DMD. So what is Duchenne really? Well, at its core, it all comes down to a tiny genetic hiccup. This error stops the body from making a really important protein called dystrophin. Now you can think of dystrophin as the shock absorber for your muscle cells. Without it, every single movement, every muscle contraction actually causes damage. That leads to inflammation, and over time, the muscle gets replaced by scar tissue and fat. Not good.
And the progression of this disease, it's just relentless. We're talking about patients, mostly young boys, who get progressively weaker and often lose the ability to walk by the time they're teenagers. And it doesn't stop there. As it gets worse, it goes after the respiratory muscles, the heart, leading to really life-threatening problems. So, and this is the key takeaway, this isn't just a disease about weak muscles. It's a whole body issue that tragically shortens lives.
Now, we do have some treatments, right? There are drugs out there, like Duvizat, which falls into a category called HDAC inhibitors. Don't worry, we'll circle back to what that means in a bit. But here's the thing. These drugs, they're really just managing the symptoms. They can help with inflammation, slow things down a little, but they are not a cure. And that's why the search for something better, something truly corrective, is so urgent.
And that urgent search, well, it brings us to a very unlikely hero. And no, it's not some famous scientist or super expensive machine. It's a tiny, transparent fish. Yeah, you heard me right. Let me introduce you to the zebrafish.
So you're probably thinking, a fish? Really? Oh yeah, this little guy is an absolute powerhouse for medical research. Let's put it this way. Testing drugs on humans? It's slow, it's crazy expensive. But zebrafish larvae? Scientists can test thousands of potential drugs all at once, super fast and on the cheap. Why? Because the little larvae just soak up the drugs right through their skin from the water they're in. It is the perfect setup for a giant drug hunt.
And it gets better. Scientists have the absolute perfect zebrafish for this specific job. It's a special mutant strain they call Sapche. Get this. This fish has a mutation in the exact same gene that causes Duchenne in people. And because of that, it shows all the same signs: the muscle damage, the trouble moving, even a shorter lifespan. It's basically, for all intents and purposes, a fish that has Duchenne.
So you've got the perfect model animal. The stage is set for a truly epic experiment. The mission, should they choose to accept it, was to sift through a mountain of chemicals to find just one, a single compound that could help these little fish and, just maybe, help people too.
And when I say a mountain, I mean it. The scientists started with a library of 817 different chemical compounds. 817. That's like having a giant bag with 817 keys, and you're looking for the one that might unlock a whole new treatment. And their process for finding that one key was super methodical. First, they sorted those 817 compounds into 185 different groups, or pools. Then, they put the tiny Sapche larvae into each of these pools. And here's the really cool part. To see if anything was working, they used a clever trick with polarized light to measure muscle health. You see, healthy muscle has this shimmer to it. It's called birefringence. Damaged muscle loses that shimmer. So they were literally looking for any drug that could make the fish's muscles shimmer again.
So this is it. This is the moment every scientist dreams of, right? After all that work, testing hundreds of chemicals on thousands of tiny fish.
The big question is, did they find anything? Did any of it work?
Yes, they did. One single compound stood out from all the rest. Its name? SR4370.
And the results were just wow. In the little zebrafish that got SR4370, the scientists saw way fewer muscle problems. That shimmer we talked about, it came back. And here's the really huge part. The treatment actually made the fish live longer. This wasn't just some superficial fix, it was a real functional improvement.
Okay, but here's a wild twist for you. Where did this promising compound even come from? Well, get this. It was first discovered during a search for something completely different: drugs to reactivate latent HIV. Isn't that amazing? It just goes to show you how a discovery in one area of science can pop up and create a huge breakthrough somewhere totally unexpected.
Okay, so we've got this really promising compound, and we found it using a tiny fish. So what's next? What does this actually mean for treating Duchenne in people?
Well, this quote from a commentary on the study really nails it. This drug, SR4370, is what's known as an HDAC inhibitor. Remember we mentioned that earlier? Basically, you can think of these drugs as a kind of master switch for your genes. They help turn on the good genes and turn off the bad ones that are causing all that inflammation and scarring. What this research shows is that, yeah, this whole approach is a really promising path for treating the muscle symptoms of Duchenne.
But you know, we have to keep our feet on the ground here. It's so important to have perspective. The study wasn't perfect. It had limits. For one, it only looked at skeletal muscle. It didn't check the effects on other critical areas, like the heart or the brain. And while the scientists know that the drug works, they still don't know exactly how it's doing what it's doing. So this is a huge, vital first step, but it's definitely not the end of the story.
So no, the story isn't over, not by a long shot. What this research has done, with this tiny zebrafish leading the charge, is give us a powerful new lead in the fight against a giant of a disease. The big question now, the one that really matters, is how do we take this amazing discovery from the fish tank and get it into the clinic? How do we take that next giant leap for all the patients and families who are waiting for a cure?